Today we're going to discuss another method for writing the electrons. When we dealt with orbital notation, we had lots of arrows and things that we had to write. We're not going to have to do that with this, but we are going to have to still write the sublevels in order for a particular element. Take aluminum, for instance. Let's look at the periodic table. Aluminum, as I've already circled up here, is a 3p element. Remember, that means that aluminum's last electron is in the 3p sublevel. So we have to write down all of the sublevels, 1s, 2s, 2p, 3s, and 3p, that occur for aluminum and that aluminum has electrons in. So let's go back to the notes. And aluminum again has a 1s, 2s, 2p, 3s, 3p sublevels. Now before we had to write the number of orbitals above each one, but we're again not going to have to do that now. What we need to do is to write the total number of electrons in each sublevel as a superscript. And that superscript is going to tell us how many electrons again are in that sublevel. All of those sublevels up to 3p are going to be full, remember. The 3p is the one that we have to worry about making sure we get the right number of electrons in it. So let's look at the sublevels and how many total electrons they can have. Remember, if it's an s, it can have a total of 2 because it's got one orbital. A p can have a total of 6 because there's 3 orbitals in a p sublevel. A d can have a total of 10 electrons because it has 5 orbitals, and an F can have a total of 14 electrons because it has 7 orbitals. So for each of these first sublevels, I can simply put, again, as a superscript, the total number of electrons in that sublevel. A 1s has 2, the 2s has 2, the 2p, remember p's have 6, the 3s, it doesn't matter how big the s is, it can be 3, 4, 5, 6, 7s, and it's still going to have 2 electrons. And now let's go back to our periodic table and remind ourselves how to tell how many electrons that p sublevel is going to have in it. So when we look at the periodic table, we see that aluminum is the first element in its sublevel. What that means is that aluminum only has 1 electron in that 3p sublevel. So when we go back to the notes, that's exactly what we're going to show here on the end. Now, in addition to writing this electron configuration, and this is the electron configuration, this is all you have to write for that, but I also want you to do the quantum number set. Now, to do the quantum number set, we're going to need a little bit more information for that last sublevel, because remember, we have to know what energy level it's in, what sublevel it's in, also which orbital it's in, and what the spin is. Is it an up or a down arrow to designate the spin for? So I'm going to put this in green because you don't have to write this, but I strongly suggest you do. Pull out just the 3p and put up its 3 orbitals, and then show where that first electron is going to be. Once you see that, like I said, you could put it on scratch paper if you want to, then the quantum number set is a lot easier to get. Remember, the first quantum number, the principal quantum number, is the energy level that it's in. In this case, it's the 3rd energy level. The second quantum number is for which sublevel it's in. So remember, we said that a p sublevel is going to be designated with a 1. S is 0, p is 1, d is 2, d is 2, f is 3. So the p sublevel gets a 1 designation. Also recall that when we're looking at the orbital, the middle blank is always 0, and it's in opposite number line order, so -1 on the right, +1 on the left. So this is going to be a +1 designation for the magnetic quantum number. And finally, for the spin quantum number, make sure that you remember that the up arrow gets a plus 1/2, down arrow gets a negative 1/2. So since this is an up arrow, it's going to get a plus 1/2. So there's the quantum number set for aluminum. Let's move on to tin. And look back on the periodic table. Tin is number 50 right here. Notice that it is a 5p element. That means its last outside electrons are in that 5p sublevel. Also notice that that tin is the second element over in that 5p sublevel, and that's going to tell us that we need to put 2 electrons in that 5p sublevel. Everything up to that point, remember, is going to be full. So we need to write all of our sublevels in order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, and finally 5p. So let's write those up. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p. So there's the order of the sublevels, and now all we have to do is fill in those superscripts to fill up the first energy levels. All of those sublevels up until 5p are going to be full. So all of the s's, remember, have 2, so it's 1s2, 2s2. All of the p's, remember, are going to be 6, so 2p6. 3s2, the 3p is also going to be full with 6. The 4s with 2. 3d, remember, if you look back up at your list, remember that the d sublevels hold 10 electrons. 4p6, 5s2, 4d, 10 again. And remember, we looked at 10 and saw that it was 2 elements over, which indicates to us that the 5p has 2 electrons in it. So to get the quantum number set, remember, let's pull out that 5p2. And we're going to write 5p again in green, because you don't have to do this on your paper. You can do this on scratch paper if you wish. Since it has 2 electrons, it's going to look like this. We're going to be finding this electron, the last electron that we wrote in. So our quantum number set is going to be 5, the fact that it is in the 5th energy level. P, remember, gets a designation of 1 for the subsidiary quantum number. The fact that this is in the center middle blank, remember, all the middle blanks, all the middle orbitals are given a designation of 0. And the fact that it's an up arrow gives it a plus 1/2 for the final quantum number, the spin quantum number. So that completes 10. Finally, radium. If you can do radium, you can do any of them. Radium, if we look back on the periodic table, it's right here. Radium, once again, is going to have all of the energy levels, sublevels, up to and including 7s. Radium is a 7s element. So we're going to go all the way through 5p that we've already done with 10. And after 5p comes 6s. And please don't forget that after 6s, we drop down and pick up 4f. And then we come back up and pick up 5d, 6p, and finally 7s. So don't forget that 4f. It's the most missed thing on the tests and worksheets for everybody. So please pick up that 4f after the 6s. So let's go back and let's write those in order. For radium, again, we have 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, I'm going to start a new line, 6s, don't forget the 4f, 5d, 6p, and finally 7s. Once you have that order written, now we're simply going to fill in all of the S's with 2, P's with 6, D's with 10, and remember, F's are 14. So let's fill all of those in. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, remember, 5d10, 6p6, and remember we said that radium was the second element over. Let's glance back at the periodic chart, the second element over in the 7s, so that tells us that radium has 2 electrons in the 7s. So going back to our notes, 7s2. So there's the electron configuration, considerably less trouble writing that than the orbital notation with all those arrows. And again, let's pull out that 7s. Remember the S only has one orbital, in this case an up and a down arrow to show that it's full. The last one that we wrote in was that down arrow, and that's 7s. So our orbital notation, our quantum number set should be a 7 for the fact that it's in the 7th energy level, a 0 for the S sublevel, a 0 since this is the only blank, it's the middle blank, and finally, since it's a down arrow, a -1/2. So those are the pieces of information that I want you to put on your worksheet for electron configuration.